AB1 DQ.
Wow.
Okay, now we got to clean up the act.
Why? That's no
'Cause you're
fun.
recording. And
Because
we have a reputation to uphold.
Right, you can't say the word fart anymore.
There you go.
I can't say fart.
No, you can't say fart.
Darn it.
Not allowed.
I was gonna make
Ed
it
doesn't want to hear anybody say fart.
I was going to make a comparison to an old fart to a new fart. What's the difference?
Apparently nothing.
Stale fart.
Come on, Ed. What's a club meeting without a little irreverence?
Nothing. Not W1 NRG, that's for sure.
Actually, the difference is between the two is one is aged to perfection.
I see.
In Germany, it's on the signs. Einfahrt, Ausfahrt.
I could expand on that, but I'm not going to go down that road.
We better not go back to 3-6. We're too rowdy nowadays.
And of course, the problem with being aged to perfection is there's nowhere to go from there.
Down.
Well, there's only one way to go, right?
Go down. All right, I'm going to make a couple of comments first before I welcome everyone. We'll open the meeting first. Thank you all for coming to the activities meeting for the month of October. Number one, I'm going to be not here this Saturday morning. So Bart N1 BRL is going to take over the coffee cup net. He has graciously agreed to do that.
Be nice to me.
So I'll be down in New York City, actually, going to see Winnie the Pooh, as a matter of fact, with my grandson and
Cool. So
entourage.
going to see a play. That's awesome, Ed.
Yeah, it is
Very
awesome.
nice. But
Yes.
Bart, will that be a pumpkin flavored coffee cup then?
No.
Okay.
You go into Radio City Music?
No, it's a place called Theater Row. It's on East 42nd Street.
Yeah.
And there you go.
A lot of places they have a play down in that city.
Yeah. Yes,
Especially-
indeed.
42nd Street.
You have to bring your vaccination card with you,
Unreal.
so, or they won't let you in. Or, yeah, or that, or proof of, I guess, you were tested. It's a, it's a law for the city rule. Anyway, that's one. Number two, just to remind those on the call about the voting, November 4th is our special business meeting, where we just have final nominations for officers. If there are none, the nominations will be closed, and then the secretary on the next meeting, November 11th, which is our regular business meeting, will place all the slate in nomination and cast one vote. If anybody wants to nominate themselves for any of the offices, they can do it now through, I guess, or bring it to the November 4th meeting, which will only be about 15 minutes regardless. Also, those who are there, who are at that meeting, and apparently only those who are at that meeting, are eligible to vote for Elmer and Ham of the Year, which is normally all done in person. But so it's a meeting people should attend. I'll send out a club announcement about it, reminding people to please show up for that business meeting on the
Can I ask a
4th.
question, Ed?
Yeah.
The secretary is going to cast one vote for the entire slate or one vote for each officer?
The whole slate,
Okay,
one vote. Not
That's fine.
votes, but one vote.
so you vote for the slate.
If no one else has been nominated, correct?
I believe that should be one for each office, I think.
Yeah, usually that's the way it is.
Well,
One for each
it's you can vote one for the entire slate as long as there are no uncontested or no
Yeah.
contested offices.
Yeah. But
That
if you
may
got
be
to
why I said that, yeah. I mean, either way, it doesn't much matter. You can do that. If you want to have 5 votes, that would be fine. If there are nominations, then on November 11th, we all have to meet physically, or you have to go down to the OEM and cast a ballot. A physically live meeting at the OEM on November 11th. 8 members need to be present and 2 officers. And
Can
at the same
have
time,
ballots?
I'm sorry?
Can we have absentee ballots?
Apparently not.
No.
Uh,
No. So again, this is COVID related, and once we get rid of COVID, we'll go back to the way we were. Apparently, you need to be at the business meeting to vote. And this is the way we modified it so that it would work out. So what we'll do is we'll review it depending on if there's any more nominations on November 4th. So there's a brief meeting on the 4th, the length of which would be decided. And then November 11th is the actual vote, one way or the other, either one vote or 5 votes from the secretary, or a physical getting down to the OEM. So there you go. And then we have December 2nd, we have a social media activities meeting where we're supposed to have a town hall, 7:30 on December 2nd, just to talk about the hybrid meeting that the club wants to start in January for our other meetings, and our social media presence, and anything else, the website, and other activities like that. I don't have a full agenda for that. It was really supposed to be open town hall meeting, I guess. So I think I'd like to have Rob and the minions run it, whoever you want to ask Rob to join you in that. And hopefully we'll have people who are savvy in that area and can fill us in on, whatever part of the social media spectrum anyone wants to talk about. And then on the 9th is the year in review. We announce the officers and the awards. And then you're all free to move about the cabinet until January when we start all over again. Okay. And then lastly, and most importantly, I have the honor of introducing Jim Cook, Whiskey 3 Alpha Papa Charlie, who is our own member. Actually, we don't often enough have our own members coming back to talk, so we're glad to have someone with expertise. Jim is going to talk to us about the Wallingford Power Grid, about which he is knowledgeable. And we're really pleased and honored to have you with us tonight, Jim. So Rob runs, I don't know if you have any slides or not. I'll let you and Rob sort of negotiate how this is handled. And do you have slides?
Nah, just all yakking.
Okay, so we'll just sit back and let you yak. Welcome, and the airways are now yours.
Okay, Ed, yes, thanks to be here. I want to thank my buddy Joe there, N1LES, for signing me up for this. Payback's a you know what there, Joe. Been a ham for 57 years. If you're not familiar with me, originally out of Pittsburgh, been in Connecticut 40 some years now, and 18 years of Westinghouse Electric, 26 years at Wallingford Electric, 4 years at Amtrak. So I've been around this area for quite a while. So a lot of it's been involved in the power industry. What I thought I'd do tonight is just dump some information out if the old bean's still working. I went down to Walgreens there, pick up some of that Prevagen, and time I got there, they were out of it. All I could get was X-Lax. So we might have some issues. But anyhow, what I was hoping to do is give you a little information on the electric division, a little bit about the electric utility here. And then I could talk a little bit about the transmission grid in Connecticut. And then I can go back and I'll give you a little information on the distribution grid here in Wallingford. So, and then maybe when we're done or whatever, Rod can bring up some questions and maybe we have a nice discussion. The electric division basically is a municipal electric utility. It actually covers 50 square miles of Wallingford and Northford. Back in the 1880s, when Edison was starting to put power plants in, the folks here in Wallingford decided they wanted one, and they couldn't get anybody to offer them or set anything up. So they had a vote, and I think it was some crazy thing like 300 and something to 2 to start their own power company. So in 1895, they started the Wallingford Electric Division, and they put a lighting plant down on Washington Street. And I guess that when it first fired up, it was basically just a lighting plant. There was no houses connected to it, but it fed 85 streetlights. So that was the beginning down there. Then eventually got up into the 50s, all the way up into the 1990s. That was the day of the A.L. Pierce generating plant. That thing is quite the little monster down there. It was a coal plant, burned coal. It was later converted to oil. It contained 3 De La Velle steam turbines, and each one would put out 7 megawatts. So on a good day, if nothing was broken, they could get 21 megawatts into the system. The thing generated at 13,800 volts, so it didn't generate into the transmission grid. It generated right into Wallingford's electric system at E Street. But it was a manually run plant, and typical plants in those days, a lot of people to run it. They had burners and high pressure boilers, steam boilers, condensers, lube oil systems, switch gear. Everything was run manually, and there was a control room right there at Pierce. And about
That's where we used to meet at.
At the power plant?
Well, but yeah.
Down on East Street. Okay. Yeah,
No, Washington Avenue.
Oh, on Washington Street. Yeah. Well, they were in the other building, in the smaller flat. You were in the was it a several story building there? It had the antennas and stuff on.
Yeah, 2-story.
Well, the power plant was actually in that building that was right next to it. So I think it was the Spanish something or another now.
Yeah, they called it SCOW.
SCOW, yeah, I think it was in the SCOW building. I actually have a watt-hour meter, believe it or not, that I found in the basement of that place that dates back to about 1903. But they tore the thing down. It was very inefficient. In this day and age, everything is, they need the power right away. They need it up fast. And I remember the time when the system operator called us. They said, we need the plant on, we need it on right away. So the guy said, sure, we'll fire it up. And the guy called back 20 minutes later and he said, where the hell's our power? And of course, our system operator told him, this is a steam plant. It takes about a day and a half just to fire up the boilers, just to get the steam up. These guys in the system operators for the state, they're used to these jets. You push a button, 5 minutes, the thing is up and running. But anyhow, 1990 or so, they took that sucker out of there, and they leased the building to CMEC. CMEC is the Connecticut Municipal Electric Energy Co-op. It's a consortium of Connecticut utilities. And their primary purpose is to purchase power. Right now, Wallingford buys all of its power off the grid. And at one time, it used CMEC as their purchase power agent. They would go into these computer setups called Oasis, and they would bid on power. The power is all market-based now. It's sold in increments of spinning power, long-term power, short-term power, a 5-minute reserve. They have a whole bunch of stuff. Now that the financial people are into it, it's all financial transactions. Well, anyhow, CMEC and Wallingford got into some disagreements, lawsuits, and I don't know what all. And Wallingford is no longer a member of CMEC. And I'm not sure who is the purchase power agent for Wallingford right now. The municipal utilities, there's 8 of them in Connecticut. Got to look at my sheet here. There's Wallingford, there's Groton, Norwich, South Norwalk, East Norwalk, which is called the third taxing district, the Mohegan Tribal Authority, Jewett City, and Basra, which is sort of odd when you figure a small state like this has that many municipal utilities, but they have the lowest rates in the United States for their customers as a rule. There's
I'm sorry,
about
what does that mean, municipal utilities? Does that mean they each have their own power plants?
not necessarily. They each have their own distribution system. They might purchase the power and resell it, but they're the electric provider for that physical area. Like Eversource and the two major utilities, the IOUs, Eversource and United Illuminating, they cannot come into the Wallingford franchise area and solicit any customers. Wallingford has that area locked down, and that's how the other municipals are. That's their areas. There's about 1,900 public power facilities in the country, and some pretty big ones. The largest one is PREPA. That's Puerto Rico. Puerto Rico Public Power Association. They have about 1.4 million customers. I think they're always broke, but they're still the largest. LA is the second largest with 1.4 million. And believe it or not, Long Island Power is the third largest with 1.1.
That Lilco, Long Island Lighting Company?
No, I don't think so. I think it's Long Island Power. I think it's a separate, I believe it's a separate entity. Not quite on the list of 100, but Taunton, Mass, believe it or not, is right up there with 38,000. They have 38,000. But Wallingford's pretty respectable. I don't know where we are in a pecking order, but we're 25,000. We have 25,000 customers, plus or minus.
And LIPA took over from Lilco.
Oh,
It was Lilco was Nassau and Suffolk.
that wasn't ready.
Okay.
That wasn't Ready Kilowatt, was it? That was Con Ed.
That was kind of New York City and Westchester.
Okay.
Can I just ask one question, Jim? You said in 1895 Edison was setting up these plants. Was that all DC? That wasn't AC?
Yeah, that was DC, I think, back in those days. This was only about 10 years or so after Edison was starting that stuff in the like 80s sometime. This was in the 90s. This is almost 10 years later. I think things were starting to roll generation wise.
Right. With
And
AC.
that's when they decided to start up the Wallingford Electric Division. And like I said, they did it with that plant. I believe that thing was coal fired. I some other time here, I could stir up some pictures that I have buried somewhere that I found of that old plant. The electric division itself here in Wallingford, it is a division of the town of Wallingford. And it's a non-tax entity. In other words, it's wholly owned and it's owned by the town of Wallingford, but it's completely run and maintained by the electric division. It's all ratepayer money. The ratepayers pay for the operation, the capital improvements. The town doesn't put a penny into the electric division. It runs itself. Now, in lieu of taxes, the electric division pays the town of Wallingford a ransom money every year in lieu of taxes. So that's what's sort of interesting. But
How much is that, Jim? How much are they paying?
I used to be a couple million a year. I'm not sure what it is now. I haven't kept track of it. Instead of paying taxes on the substation locations and all that stuff, in lieu of that, they give the town cash agreement. I'm not sure what it is. I think it's 1.4 million rings a bell, but it's probably higher than that now. The electric division's it's just like a regular utility. They have the same thing. They got to do everything that UI and the IOUs do. Wallingford does. And maybe I'm bragging a little, but they do it quite well. They have a line department. They have 9 bucket trucks. They have digger derricks, all the equipment, line equipment for installation. They have a meter department with 4 or 5 guys. These guys install the meters, remove them, do periodic calibrations, repair. And if you're lucky enough to not pay your bill too often, it'll come take your meter back. They have a substation maintenance group, which is, these are fairly highly skilled technicians that take care of the substation switch gear and communications gear. They have their own business office that handles all the customer accounts and what have you, billing and all those type of things. They have their own engineering, distribution engineering down there. The engineer that comes out and looks at your house before you hook it up, he's going to decide where the lines can go and what have you. That's all in-house. Same thing with drafting. They have their own draftsman. And then they also have a operations group, which actually run the system. I'll get into that in a little bit. Those are the system operators. And one thing is Wallingford has done is they leased land for what I call the peakers. They leased the old Pierce plant. They leased it to S.A.M. So S.A.M. come in and they put in a 80 megawatt jet, natural gas fired, but it has oil backup. And it's only used for peaking. Whenever the grid is really low and those doggone short time prices climb up, they put that online because they make a ton of money. But normally it doesn't run. I do believe right now, though, S.A.M. is offloading that plant. It's being sold to Hall Energy. Hall Energy is a, you guessed it, equity financial type organization. They don't really deal in anything other than dollar bills. They're in the process of buying it. And the other part of the property that's leased out down there is is what we call the PP&L. PP&L leased some property right behind Pierce, and they put in 5 50 megawatt jets. If you're familiar with the aircraft stuff, they're LM6000s, and it's a self-contained unit. It's 50 megawatts. Goes from 0 to 50 megawatts in 10 minutes, a full load, completely controlled via SCADA from Allentown, Pennsylvania. Guy in Allentown touches his screen. One of these 50 megawatt jets starts up over there at East Street. And in 10 minutes, it's online providing. Make a long story short, PP&L is now out of that business. And they've sold it to, I think the current owner is LS Power, which is a outfit that buys and sells power plants. But here's something that's interesting. You know, it's all market, like I said before, this whole market stuff's all market driven. A couple years ago, the system operator called and said, we need power on the grid. We need it right away. PP&L had 350 megawatts they could have put on the grid. They said, nah, we don't want to run today. They said, well, here's the prices. The prices are really high. We need you to come on the grid. They said, no, we buy gas futures. And our gas futures, we're making more money selling our gas futures than we would running the plant. So we're not going to run today. Of course, I'm old school from the old days where if you were the electric utility, you made the electricity, you sold it. And but today, like I said, it's all a market driven type thing. We also had, I think, 6 or 7 at one time, 2 megawatt gen sets. These were truck mounted. They were parked all over the place. S.A.M. had those and they used them for peak shaving. And again, whenever the price would go cuckoo, we get calls to fire those peak shavers up. Those were diesel units. But anyhow, that's sort of what's going on, you know, there at Wallingford.
What's a peak shaver?
Well, whenever load is really high and they need to cut the load down, they can bring these on, and they put that on to help shave the grid's peak. But the grid pays big bucks for that. You know, in other words, we need you to help us. We have too much load. We need more power. We need to shave the peak off. We're going to pay a small fortune. You bring your peak shaver on, and it generates power, and that's primarily when they would run that. They still that when they run those things. None of those generators, none of those jets run full time. Standard load. You know, in the old days when the steam plant was there, that thing would chug along almost forever. It was always going. But the jets are, they only come up when they need them.
Jim, that peak, does that peak have to be in Wallingford? Or could it be anywhere in the country?
Well, on the grid, it could be anywhere in the country. Yeah, this is when the system, remember, I didn't get into it yet, but I'm almost there now where I'm going to talk about convex. They're the system operator. They're the ones that determine whether they need more power onto the grid. And they'll say, we need more power. And here's what, you know, and then it goes into the financial stuff. And all of a sudden, you know, instead of $13 a megawatt hour, they're paying $142 a megawatt hour. And that's when these guys in PP&L would say, well, let's fire up the jets. We're going to make some money today. So they would put those jets on the line.
So how many megawatts does it take to run Wallingford?
Wallingford on a busy day with a fairly heavy load. I know when Bristol Myers was still here, I want to say 140 megawatts.
So what you're talking, what happens when the grid collapses and everything gets a blackout? Can't they just fire up the point shavers and turn them on or something?
I'm gonna get to that if you hang in there.
All right.
Yeah,
All right.
I have a little bit of information on that.
At least I'm listening. There you go.
Yeah. Let's go into the power grid in Connecticut. The power grid is it's 115 kV transmission grid, and it's 3-phase. Now, of course, a lot of the hams are used to single phase and DC and what have, but remember, this is 3-phase power. There's three separate wires, if you will, and the voltage is 120 degrees apart. So you got all three of these. This is old Tesla's work, and the voltage is 115,000 volts between any one of those two wires, and 69,000 volts to ground. So when you look out at the transmission towers that you see up there by Lowe's, Home Depot, or down here at East Street, you normally see 3 wires hanging there on the line. That's each one is a single phase of a 3-phase system. You know, 115,000 volts. Now those things run upwards of 1,200 amps. So if you want to get your calculator out, you can calculate 1,200 amps at 115,000 volts. They run a fair amount of power. And Wallingford is connected to this statewide grid. We have stuff comes from Southington, Devon, Hanover, and Middletown. So before Ed had asked, I was saying 140 megawatts. That doesn't come from one area. In other words, down there at East Street, where that those 350 megawatt plant is, we couldn't take 140 megawatts out of there and easily get it all over Wallingford. It would have to go into the grid, maybe go to Southington or somewhere else to get up to Colony or to North Wallingford. So everything is dependent on this 115 kV grid. Now, in addition to that, the state has just put in some 345 lines. It's 345 kV. Those things vary. Transmission lines vary. I worked at Westinghouse on some stuff we sold to, I think it was Africa or somewhere. We went up to 765 kV, 765,000 volt transmission line. A big thing out in the Midwest and what have you for long transmission lines, believe it or not, is DC, high voltage DC, because AC is what they call skin effect. You study for your advanced license there. The higher frequencies want to travel on the outside of the conductor. So if you run on DC, you can get more amps per circular mill of wire. So you run a 500 kV DC cable. But here in the East, they don't run those. They're just too expensive to put up. They need special inverters and what have you. So again, sort of an old system here. There's even older stuff around. Stanley Tools in New Britain had their own 69 kV line. It came from a hydro plant on a river there somewhere. It traveled up through Hartford and West Hartford and right to the plant. They had their own 69 kV transmission line. Okay, that said, Convex, that's Connecticut Valley Exchange. They are the systems operator, grid operator for Connecticut. And they're physically, they have several control rooms, but a good bit of it's up there in Berlin in some of the Eversource buildings. But they operate the system, they coordinate all the maintenance, and the switching that has to be done is all done through them. And they also control the voltage loading, and they control the frequency. One of the things that's really important on a transmission grid is the frequency. And of course, to change the frequency, how do you do it? You gotta crank up the generator. You have to speed the generator up if you want to bring the frequency up, or slow the generator down to bring it down. And being the grid is all tied together, the whole grid is dynamic, and it floats around almost like a cloud. I've seen grid charts, I've seen frequency charts where a nuclear plant tripped offline in Louisiana. And we could see that on the frequency here in Connecticut. The frequency here in Connecticut changed. But one of the things with that grid is, as you know, you can't store electricity. You can't make it, put it in a bottle, and keep it until you need it. You can only make it when you're using it. So that's how they control it, by changing the speed of these generators. Now, a lot of that's done by computers and it's automatic, but it's also done by loading. If you put more load on, you're going to slow this generator down a little, or you take some load off, or you switch load, and that's what Convex does. They're the system operator, and they do that by what they call a SCADA control. I'll get into that in a little bit. They can control all of the substations in Connecticut except ours. Wallingford controls their own substations. They do give Convex some indications, that they can read things and look at things, but Wallingford, they run their own system. The voltage adjustments are all done by what they call tap changers, and it's just like a transformer. You change the taps. They have load tap changers and no load tap changers. But anyhow, by changing the taps, you can change the voltage. But what's really interesting on a three-phase system, when something goes wacky, it really goes wacky. I've seen 121,000 volts on some of those transmission lines, and I've seen voltage just going all over the place, and the frequency jumping all over the place. I said you can't store electricity. You can somewhat store energy. Don't get me wrong. I don't know if you're familiar with Northfield Mountain. Northfield Mountain in Massachusetts is a pump station, hydro pump. There's a big reservoir up on top of the mountain. At nighttime, when there's not much of a load, they run everything backwards. They use energy because there's extra energy floating around. It's not needed. They use that to pump the water up into the reservoir. Then in the daytime, when the peak load gets nice and high and they need more power, they flip it around, open the gates, and they run the water back down the mountain and use that to drive the hydro generators to make more power. The generators in this area, like in Connecticut, are there's Millstone. That's the nuclear plant. I forget what that is. 1,200. I think it's a excuse me. I think it's a 1,200. There's generating plants at Middletown, Devon, and again here there's some at Wallingford. There's some other plants too. The Mashantucket Peak, which they have some of their own stuff over there. Ed wanted to know what happens when the crap hits the fan and the lights go out. When I was at electric division, in order to be a convex, what they call a convex licensed switcher, there's a lot of training and stuff you have to go through. And one of the items is a flat recovery, where you have to, everything is dead and you need to bring the whole state back up again. Well, they have a simulator there, similar like an airplane simulator. This is the grid simulator. And we went up there and spent a couple hours one day where each team had to go ahead and try and restore the whole state went down and you had to restore it. Well, it's not as easy as just starting up a generator. First of all, how do you start a generator? First of all, you got to get a generator that has something to start it. So it just so happens PP&L plant here in Wallingford has emergency start diesel powered generators and compressors. They have a humongous big diesel generators. They can start those up. Once they start one of those up, then you can start up a jet. But the jets aren't all that simple. You can't start a jet up if you don't have any load. A jet won't run. It doesn't like to run without load. So the switcher has to figure out, okay, we're going to start this thing up and we're going to close it, and I need 20 megawatts of load. So you're going to close all these switches here, there, and whatever to get the load onto that generator. And anyhow, it goes from there and it just goes right around the state. And I might add, the crew that I was on, the 4-guy crew, that we did pretty good. We got the power back on and went to lunch while other guys were still farting around trying to get the thing to work. That's all done on SCADA. Everything is controlled that way. Let's see my notes here. So that's basically the grid itself. The substations now. Substations are places where the grid ties into the substation, and that's where all the conversions are done. The 115 kV voltage is converted down to typically 13.8 kV. And there's typically in a substation, there would be a 150, we call 115 yard. Transmission line comes in, goes through some switches, goes back out again. These are humongous switches, probably the size of an automobile, maybe stacked up too high. They run on SF6 gas, insulating gas, or they have oil in them. I think right now we got everything down to gas circuit breakers at 115 kV. And those transmission lines there are tapped off and they go to power transformers. Now these are typically, North Colony substation has two 50 MVA transformers up there. They're 50,000 megavolt amps of 115 to 13.8. So that converts the voltage down to 13.8. The 13.8 goes into what they call a switchgear house. The switchgear house has what they call buses. It's really copper buses that are physically, an inch thick and 6 inches high, and they run through this gear, and they're all tapped off to these different breakers. So these big transformers are feeding these buses, and off of those buses are 13,800 volt circuit breakers. Those circuit breakers open and close, and they run what we call a feeder, a distribution feeder. So there's about 30 feeders in Wallingford. Actually, there's probably more than that. But each feeder from a substation is what we call radial. It leaves the substation and it meanders out through town, and it doesn't, for the most part, doesn't connect anywhere else. It doesn't parallel with anything. It's just a radial feeder. And those feeders run, they have typically 2,000 amp breakers, and they typically run upwards of, let's say 700 amps something like that on a given day. So you'd have 13,000 volts at 700 amps on one of these feeders. A 700 would be a little high. 400 to 500 would be a normal load. There's a lot of protection on that. I'll go into that in a little bit. Those relays have all kind of smart relays, Schweitzer, General Electric, to name a couple. And those relays are looking at the current and everything that's going out of those things in case something happens out there. Mr. Squirrel blows a fuse or whatever. They can trip the breaker. But one thing those smart relays also do is, I mentioned the under frequency. One thing FERC is, that's the Federal Energy Management. They're really big on under frequency, and they're finding utilities that don't have it set up properly. If the frequency, if the grid goes to El Crapo and the frequency starts to dive, there's certain points where the utility has to shed a percentage of your load. So if it goes from 60 cycles down, 59, 4, whatever it is, at set point 1, you have to shed maybe 1% of your load, and then it hits the next point, you have to shed it. And you have so many seconds, to do that. So we have matrix boards in all the substations, and our engineers have determined what loads will be shed if there is an under frequency excursion. And, we always keep a couple of restaurants handy for the linemen, but in the hospitals, we have to actually decide who we're going to shed load on if we have to go. But these relays are so smart. When that frequency on that feeder hits that frequency point, it trips that feeder off if it's one of the ones that's is selected. So that's how it's done. It's all done by engineering calculations. The substations themselves are pretty smart. They're autonomous. If the SCADA conks out, if the phone lines are all down, those stations will sit there and run by themselves. They have 66 cell, 125 volt, 2000 amp batteries. You could run your QRP rig for about 200 years on the battery system in there. Everything in there is 125 DC, the lights, the fans, the everything. And so if something happens, that station will run by itself. And for the most part, most of the functions during the day, it does run by itself. So once we're out of the substation now, so we brought these feeders out of the substation, they went through the switch gear. They come out of there and they go up the poles and down the street. And at one time, we ran about 7 or 8 feeders to 10 different substations. Very inefficient. We ran 13.8 to Northford, to Dudley, Pierce, Cook Hill, Parker Farms, Center Street, Yalesville. Everybody had these little substations. But the little substations, they took the 13.8 and broke it down to other voltages. Those other voltages were all different, unfortunately. Is whenever they bought the stuff is what voltage it was. So we had 4,800, 2,400, 4,800, 4,160. So if you lived in Yalesville, off of the Yalesville station, that was I think that's a 4160 station. All the transformers in Yalesville had to be 4160 to 24120 to feed your house. So they had to stock transformers for all these different voltages. So anyhow, while I was down, one thing that they did was replaced all those stations and took them all out of service and put in just the 3 main stations. And now all the feeders are 13.8 feeders are single radial feeders. So every transformer in Wallingford will be connected to a 13.8. We no longer have to worry about carrying all these different transformers and what have you. You probably notice when you're driving down a street, there's what we call Hendrix wire. You look up there and you see 3 conductors hanging on a messenger, and it looks like about a 6 or 8 inch spider up there with the 3 wires on it. Those are the 3. If you see that, that's a feeder. That's a feeder circuit, and it would normally have the three phases, and the top is the neutral or the messenger. And one thing we did, in fact, my old boss, I give him credit for this. He bought 25 kV wire. That's only 13.8 voltage, but instead of buying 15 kV wire, he spent the extra money, bought the 25 kV cable. That stuff can hang up in a tree and stay there indefinitely. And it just, for the extra money that they spent on that 25 kV cable, it holds up quite well. So on some of those feeders, there's what they call reclosers. A recloser is nothing but a pole mounted switch that cuts on and off. It has a smart relay in it. If Mr. Squirrel downstream there gets his butt on an insulator, the recloser will detect that. Just about the time he's, ready to be go with the French fries, it opens up. The recloser will open up, and it will wait 15 seconds to see if Mr. Squirrel decided to evaporate. Then it will close that circuit back in again. And it's what they call a 3-shot recloser. It does 3 shots. And the idea is every time there's a shot, there's a certain percentage that you should clear that fault out here. Sometimes there isn't. Sometimes the recloser will go 3 times. That's why if you're out somewhere and there's a fault and the lights go out, don't mess with the wires, because that recloser is timing, and it might just decide to put another shot into that feeder. But the idea behind that is to sectionalize. So if it says there's something wrong out there, the recloser stays open and it leaves that part of the line dead. So what happens now is the line crew comes out and they say, what are we going to do? We get this section of line that's dead. There's gang switches around here. You'll see them up on the poles. And we don't have any SCADA operated gang switches, but they're all manual. So, or motor operated, the guy has to go flip a switch. And so by opening and closing circuits on that Hendrix, they can say, well, we're going to cut in this other feeder to that end over there. We'll open something else up. And that's how they can segment the power sections on the distribution till they get it done.
Jim, it seems to me 2 things. One, how vulnerable is all of this to cyber hacking? Like what shut down the power grid.
Well, I'll tell you what, in 2 seconds, I'll be there.
All right. The other thing is,
I was reading my mind.
when I see guys up on the poles fixing things, or they don't look like, although they're, I'm sure, hardworking gentlemen and they're all good citizens and God loves them all, but they don't look like they all have PhDs in advanced physics. So are they taught to do like one job so that they don't have to understand all of the physics of all this stuff?
The linemen go through an apprentice training program, which I think lasts like about 4 years, and they do nothing but line work. And they're skilled at doing the line work. They don't necessarily get into doing any. In other words, they wouldn't go into substation, do any of the substation work and what have you. As far as hacking goes, I'm going to get into the SCADA here in a minute. And, yeah, we could talk about that for the. Again, so now we're at 13.8. All the feeders on 13.8 kV. The distribution transformers are all 13.8. And typically, a can that you see in front of your house more likely is probably like a 25 kVA can. And it depends on how they hook them up. They can hook up about 6 houses or so to one of those. If you see one of those with the little red light on up there, all that means is the oil got hot in there. It doesn't mean that it tripped out or anything wrong with it. It just meant it ran hot. And usually the linemen, they don't report that because they'll wait till it blows up, then they can get a trouble call out of it, for but all the transformers in Wallingford have been sampled for PCB. We hired a contractor and came in, and he actually took one of these Hilti guns, shot a hole in every transformer, took a sample, cost a fortune. And any transformer had PCB oil in it, we got rid of them. That cost a fortune to get rid of those. The PCB is great oil. I used to, you see, before I lost this, I think that's why I lost this, is I used to put PCB oil in the transformers at Westinghouse. the PCB oil is a great transfer. It's great for transferring heat. Heat goes through PCB in it. So in a transformer, the best thing you can do is use PCB oil, and it has high dielectric value and great heat thermal, and it has a low expansion. It's just perfect for a transformer, but it does burn. And when it burns, it gives off furans. Furans, cancer. So it's been a big no-no. So anyhow, the oil is in these things now is a mineral oil that they use in the transformer. And that's pretty much a distribution system. Now the SCADA system, this is where we get into the ham radio part of this thing, is a 9600 baud, pretty dumb, right? MAS, a multi-point distribution system, 2 frequency. It runs a big, powerful 7 watts of power. And it runs at 9600 baud. So why do you want to run it so slow? Well, because it's reliable. It works. It's redundant. It works every time. And it's on 900 megacycles. So it's all line of sight. The antennas are very directive. If you would try to get in here to hack it, you'd almost have to drive underneath one of the poles to get up there. The SCADA system itself for the computer guys, it runs a Linux Red Hat operating system, which is very reliable. HP servers, workstations, everything is redundant. The RTUs, that's the remote terminal unit that lives in the substation. So it talks to the system master. The system master transmits a 900 megacycle signal continuous. And what it does, it's a polling system. It will send audio out, well, actually digital, and it will say station number 1. Well, when station number 1 here's its code, it will respond on another frequency, half duplex, back to the master. And that's how they talk. The RTUs are remote terminals that live in the substations. They're connected to just about everything in there. They're connected by a wire, RS-232, some of the other serial port, and also fiber. There's a fiber from the RTUs that run directly into the feeder relays, because you get a lot of static and RFI and interference gets into sensitive electronics. That fiber, you don't get into that. So we run the fiber right into the right into the relays. That said, the system operator is down there at John Street, and that's manned 24 hours a day. They can monitor and take care of everything on the system. They can open all the breakers, close the breakers. They're in a lockdown control room with the system security. And like I said, if the SCADA quits working, and again, everything is redundant, even the radios are redundant, the 2 of them running at the same time. If something happens, the stations are smart enough that they run by themselves. That said, the substations and the grid stuff in the substations requires protective relaying. And the protective relaying keeps all the grid breakers and the distribution breakers, sort of keeps those in line. Just to give you an example, the new ham band, what is it? Is it 2600 meter? The BLF band that they just opened up. If you go to use it, you have to file with utilities, UTC, because they go to the local utility to see if there's any low frequency relaying equipment that could be interfered with. Well,
2200.
2200, okay. Yeah, Wallingford runs some stuff that's typically like 136 kc. And this stuff is from the old days. They got vacuum tubes, incredibly reliable. The stuff that's there now is probably still transistor. It's a 10 watt transmitter on let's say 136 kilocycles or kilohertz, and an RG8 going up the pole with an insulator, and it injects it through a big capacitor right into that 115 kV line, And that 136 kc signal goes to Devon, 23 miles away.
Sounds like a
That's used for blocking and signaling. Depending where the fault is, it will send signals, tell it to trip or not to trip or whatever. Well, they decided to put the transmission line from Wallingford to Devon underground over there in Cook Hill. Well, you can't run power line carrier underground. It just don't go through the dirt. So what we did is we put in fiber, and we have a 25-mile fiber line that's in the static wire on the 115 kV, that top messenger wire you see up there. That's all steel conductors with 50 heavy duty fibers in the middle of it. And OPGW it's called, and optical fiber. So our Wallingford station is connected to Devon through fiber, and the relays, they talk back and forth all day long. If something happens, they can get it. Again, these relays are so smart. Just an example, up at North Wallingford substation one day, we lost a phase on one of the transmission lines. It tripped, relay tripped out. So we went up there, took a look at the relay. Relay says phase A to ground, 350 yards. And it tells you exactly what phase it is and where the fault is on the transmission line from that point. So the electricians, geez, that's down the street. So sure enough, they went down the street, they found a tree right up against the transmission line. The tree had blown out of the woods and somehow got up over it. Anyhow, but the relays are smart enough that they can detect trip, and then they can also display the fault indication. So anyhow, that's pretty much in a nutshell what goes on when the lights are working. Any other questions or?
Jim,
What about?
Hey,
solar?
Jim,
What
Yeah.
about the solar?
when I moved in to Wallingford about 35 years ago, the welcome wagon lady came around and she says, you know, you probably don't know it, but the voltage in Wallingford's higher than everywhere else. So you might want to buy these heavier duty light bulbs.
Higher voltage rated bulbs. Yeah, when I came here, that's the first thing. The welcome lady actually brought me a box of bulbs. Thinking, what the heck is this? So later on, I come to find out that, again, this is back when we were running all these other little stations, and there's voltage drop all along those feeders. So, well, here, I'm in Yalesville, so the voltage at Yalesville went through like 5 breakers and 5 little circuits that went out through the streets of Yalesville. There was enough load on there that the station was overloaded. So what they did is they jacked the voltage up on the station so that in the daytime, in peak hours, the voltage would be okay. In off-peak hours, the damn voltage would be high, and you wind up with 126, 127 volts. And you take a 120 volt bulb at that voltage, they don't last long. So that's why everybody was running 130 volt bulbs. But now everything is on the 13.8. Everything's pretty well regulated. You shouldn't need yeah, but I remember those days for
Well, it's got a question.
What
Yeah.
If
about,
Wallingford buys its electric off the grid, why is it so much cheaper?
well, they tend to buy it in long-term contracts. Like I said, now that the financial people were involved in it, you can buy it in different. You can say, well, I want so many megawatt hours at a fixed price, but then if I have to buy some at another price, we only want to buy so much of that. It's sort of like cutting up a pie, and that's how they do it. Why is it cheaper? I don't know if I can. I never got paid much. Maybe that's.
what about the solar panels that are springing up?
I don't know. When I was there, the management team was sort of against the solar, and I'm not too sure why. I did the metering design and everything for that choke Kaufman building up there, and Proton Energy put in some stuff. And originally, when the solar panels started, there were a lot of sort of fly-by-night outfits were going around trying to raise money different ways and what have you. So the electric division decided to stay out of that. But I don't know who's involved in these solar panels down there now at the dump. I'm not sure. Here at the Yalesville Airport's loaded with solar panels too. But I don't think the electric division's involved in that. They do approve residential solar. You want to put solar on your house. I've seen a few of those.
Jim, I'm still, if you can simplify layman's terms, because I'm pretty stupid on this. So there's a big load in California. Something's going on. It's 120 degrees and everybody got their air conditioners on. How does us putting on our 4 jet engines over there on the plant help that load?
Well, there's what they call interties between these. I wish I had the map. There's about 4 or 5 areas that are basically sort of independent. They're not connected to each. They're connected, but they don't flow anything back and forth. If they get into trouble, they go to the next sector over and they say, "Hey, we got a problem here. We need some more power." In Connecticut, for example, there's 2 hydro lines that come down from Canada down through Vermont, and Convex gets a hold of them somehow, and we can bring in more power if we have to from that other area. That's what happened to Texas, though. Texas was independent, and they said we don't want to tie into any other places. We're Texans, and we don't.
And we're stupid.
Yeah, we don't need that. So, and then they got compounded problems where they didn't winterize those jets. Those jets have to be, the lube oil has to be warm and all that kind of stuff, which the ones here have that because in New England, they're used to having that. But in Texas, they didn't have it. So they hit the cold spell, the natural gas froze up, the jets wouldn't start, and they had no lines connected to any other states to bring in power. So I think that's where they got into trouble.
And
I don't know if I answered your question there, Joe. I don't know.
I guess so. If they're drawn from the next sector, then they can go to the next one. I don't know how they see that additional 20 megawatts.
Like I said, it's like a big pool of water. If way over here the pool's going down, and over here, on the other side, you start throwing some more water in the tub, it's going to eventually sort of get over there. But I don't know that the Wallingford Jets will do anything for as far as California goes.
Yeah.
But
as far as the Wallingford residents, man, I've lived here 35 years too, and nothing but good words for Wallingford Electric. I think we lost power twice in 35 years. Once or twice was probably Mr. Squirrel across from Ed's house there.
We used to get in, my boss and I, we used to get in trouble. I heard him taken to task of why did he spend extra money on that 25 kV insulation for that wire? He said, "Well, why did you spend that? You didn't have to spend that." He said, "No, but I felt we needed it."
Yeah.
We had, and that goes on in a municipal government issue where town councilors and stuff sit back there and look at some of these things, although they have. That's another thing. The electric division has its own public utilities commission. They do not report to the state of Connecticut. They abide by the Connecticut rules and regulations, but they don't report to the state, and they have their own PUC commission, so they can set their own rates and what have you. And that's a political, those guys are appointed for.
Yeah. And as you know, I worked for a radio shop, and we took care of a power company to the south of us here. And I think they had backup radios and the SCADA in their substations, but we used to have to check that once a month.
Right.
900 mega radio, we'd have a little keypad and punch in a code for each station. And it would say, "Okay, station 36, you hear me?" And if it was working, it would come back and say, yeah, I hear you. Well, it would say, okay, or whatever on a little readout. But how many stations every month did we find the SCADA wasn't working and UI did, oops, that power company didn't know it was working.
They didn't know it was working. Yeah,
told them.
yeah. But they know it here because there's only 3 stations, and the system operators, like I said, they're 24 hours a day. They're sitting at a console down there, supposedly keeping an eye on things. In fact, they're actually tasked with taking readings and what have you to sort of keep them occupied a little bit, because the thing's so smart they could just sit there. But it is pretty interesting. Like when one of those jets comes up, the signal comes on, a little red light comes on the panel there, and it says start up. And all of a sudden, boy, out in the yard, you hear bam, and the breakers close, and the gas pumps start up, and the next thing you know, the jet fires up and picks up load, and the main breaker slams shut. In 10 minutes, there's 50 megawatts going out there.
Do you ever remember hearing neighbors down there because they didn't run all the time when they started calling up saying, what's the noise?
Yeah, there was some issues there. There was people that complained about everything. Although, the old oil plant there, that thing would run rich sometimes. And when I mean rich, it was puking soot out the chimney, and the ladies got their sheets on a line in the back there. They would well, there was a lot of things they did to mitigate that. There's a sound wall down there around those 7 jets. That sound wall is only about 1.5 feet thick, and it's probably 25 feet high. And I kid you not, you could open the door and walk out of that sound wall and close the door. You could stand there and talk on the other side of it when those jets are running and carry on a conversation. And on the other side of that wall, the noise is over 100 and some dB from the jet. So that sound wall works pretty well for.
Hey, Jim, what percentage of the telephone poles does Wallingford Electric own?
Half.
I'd say probably 3/4. I might be wrong. Some of them are also owned by SNET,
right,
or Frontier, and like Joe said, there's a utility that owns some phone poles in Wallingford that they don't take care of them, and you'll see around town where maybe you'll see a pole that's been broken, and somebody put a patch on it, with 2 other poles and some bolts, and that's because it's not our pole. Our guys can't change it; they don't own it, and the other utility has to come change it. Sometimes they go for years before they get changed. Although now that Frontier's in here, I think they are doing a little more line work. I've been retired for a number of years, so I'm not too sure what goes on down there.
Jim, you mentioned briefly about running power underground, and I've seen that before where you can't run a lot of power underground, and I wonder why that is. And is it because of the heat buildup, or?
Well, you can. You got to have special cable and what have you. It just gets extremely expensive to do that. I know at the S.A.M plant, that 80 megawatt jet, the cable that goes from just in the building underground and it pops up in the yard costs a small fortune to put that cable in there.
Is it a physical limitation, or?
No, I don't think so. Well, one thing I was saying does not work underground is the power line carrier. If you're sending a 136 kc signal down a power line, the 136 kc and the power line goes underground, the power line is just not going to be the power line carrier signal is not going to go underground. It absorbs all the signals. So, and of course that's sort of pretty old technology. That's been around for years. So if any of you guys go on that band and you hear something, you're probably tripping a relay somewhere.
And 2 years ago, they changed the underground power cable on my street.
Okay.
They said it was just precautionary.
Yeah, I
was
think the way it
getting
is in
old.
Wallingford, the association, I believe, owns the underground in some areas. Other areas, I think, I'm not sure. There's a whole bunch of legalities there as to who owns what. In some places, the owner owns it from the transformer to the house. Underground power is great. You know, you don't have to worry about the trees and what have you. It's just incredibly expensive.
Yeah, they had to dig up, go across driveways, go, down the street. First then they had to put in the conduit, then they had to put in the cable. It took a while.
I've seen some houses where they put new underground cable into the house and then they couldn't get it sealed. So that the pad mount transformer, 3 houses up the street, the base of the pad mount was filling up with water. And it would go in the conduit, even though it was sealed, run down the conduit, and it was coming out, squirting right through the meter box into the customer's basement, Yeah, so.
All right, any other questions for Jim?
Yeah, I didn't put any pictures there. Sometime you want to see some old time pictures, I might have to look
Well,
around.
it might be a good idea to, if you can find some old time pictures, to talk to Bob, Railroad Bob, and maybe put an article in Key Clicks with some pictures. Might be interesting.
I did send him a picture of my new ham radio. Did you see that in the Key Clicks?
Yes. Yes, that was a good one. Good one.
Little mustard on there.
All right, any other questions?
Nothing from the chat, guys.
All right, well, thank you, Jim.
Okay, thanks, Sam.
Appreciate it.
Yeah, very interesting.
Yeah, thanks, Jim.
Yep.